Namaste students. Today we are going to see the lesson optics. The topic is lenses. Topic is lenses. Already we have seen the properties of light, scattering of light. What are the scatterers? According to the scatterers and the energy, kinds of scattering in the light. What are the kinds of scattering in the light? What are the kinds of scattering? First one is Rayleigh scattering, Mie scattering, and then Tyndall effect and Raman scattering. These are the types of scattering according to the scatterers. According to the scatterer. By the energy, the scattering is divided into two types. What are they? Elastic scattering, inelastic scattering. Isn't it? Next upon dispersion of light. According to the wavelength, how the acronym BIBZR will be divided. Through the video also we have seen. Now we are going to the next topic, lenses. Okay, lenses. What are lenses now? Lenses. We are using lenses in our daily life. In the doctor, dentist use the concave lens. Concave lens. In the vehicles, we are using the lens. In the spectacles, we are using the lens. Isn't it? Yes. So what is lens? Lens is a transparent medium. What is transparent? We can see the object through that. That is transparent medium. That is transparent medium. Okay, ma? So already we know that what is transparent, translucent and opaque object. Lens, transparent medium. Understand? So the lens is an optically transparent medium. Optically transparent medium bounded by the spherical refracting surfaces. What is reflecting, not reflecting? Reflecting surfaces means mirror. Okay, here refracting surfaces, spherical refracting surfaces are one plane and one spherical surface. Understand? First of all, you see that converging lenses. This is one type of lens. Convex lens. In the convex lens, first one, you see the first one, two spherical surfaces are present. Okay, ma'am. One is plane surface, another one is spherical surface. Spherical surface. So, two faces bounded. Two faces are bounded. Okay, ma'am. So, first one, you see the first one, converging lenses. The first one, convex lens. In the convex lens, one surface is blended, another surface is spherical. Next, biconvex lens. In the biconvex lens, two sides are spherical. Okay, ma'am. Next one is plano-convex lens. Plano-convex lens. This only the, you see the arrow mark. Okay, ma'am. This is the plano-convex lens. In the plano-convex lens, one surface is flat. One surface is flat. Flat surface. You see that. This is the flat surface. This is the flat surface. Okay, ma'am. Next surface is the spherical surface. Okay, this is the next one is positive meniscus. What is positive meniscus? The outwards of the lens. The lens outwards is the refracting surface. Refracting surface, not inwards. In the convex lens, the outward surface is the refracting surface. So this meniscus is called the positive meniscus. Understand? This is the one type of lens. What is lens? Lens is an optically transparent medium bounded by two spherical surfaces. Spherical refracting surfaces. What surfaces? Not reflection. Refracting surfaces or one plane and one spherical surfaces. Okay? Yes. Next, this is the first one is converging lens. Converging means what? Converge the rays. These lenses can converge the light rays. Converge the light rays. Next one is diverging lenses. Next one is diverging lenses. Diverging means what? this diverge the rays. This diverge the rays. When the rays falls on that lens, that will diverge the rays. Understand? So this is diverging lenses. These are diverging lenses. Here, first one is concave lens. This is the concave lens. In the concave lens, the inverse here is the refracting surface. Inverse. First one is concave lens, convex lens. That is the outwards is the refracting surface. Here, inward is the refracting surface. Refracting surface. This is the concave lens. Yes. Next one is first one. This is the one surface is the flat surface. This is not the refracting surface. This only the refracting surface. Next one is biconcave lens. Biconcave lens, both surfaces are refracting surfaces, the inverse surfaces. Okay, this is the biconcave lens. Biconcave lens. Okay, convex lens means outwards. Concave lens means inwards. Okay, next is plano-concave lens. What is plano-concave lens? One surface is flat. Another surface is inverse. Inverse. Okay, understand? So this is the plano-concave lens. Next is negative meniscus. What is that negative meniscus? The refracting surface is inverse, so that is called the negative meniscus. Negative meniscus. So these are the two types of lenses. First one is converging lenses. Next one is diverging lenses. Yes. Now we go to the next step. So lens is basically classified into two types. They are convex lens. Another one is concave lens. Convex or biconvex lenses. Biconvex lenses. Now only we saw in the picture. That is, it is a lenses bounded by two spherical surfaces such that it is thicker at the center than at the edges. Understand? In the center of the part is thicker, and then going on edge is thinner. Understand? So that is the convex lens. A beam of light passing through it is converged to a point. Beam of light. A beam of light passing through that will converge at one point. Okay, so the lens, the convex lens have the ability to converge the beam of light. Converge the light rays. Understand? So a convex lens is also called as converging lenses. Understand? So that is the converging lens. Next, concave or biconcave lens. Okay, it is a lens bounded by two spherical surfaces. Two spherical surfaces such that is thinner at the center. In the center part is thinner, but the edge part is going on thick. Going on thick. Understand? So center part is thin, going on edge is thick. So a parallel beam of light passing through that, it is diverged or spread out. Diverged or spread out. So a concave lens is also called as diverging lens. Yes. Next, what are the other types of lenses? Now only we saw that now the picture only. That is plano-concave lens. What is that? One of the face is biconvex lens is plane. One of the face is plane. Another one is spherical. So that is known as plano-convex lens. Next thing. Plano-concave lens means what? One of the faces is plane and then another one is inwards. Okay, so it is also known as, that is a refracting surface, that is plano-concave lens. Okay, these are the types of lenses. Is it clear? Okay. Now we are going to the image formation. We are using the lenses in the specs. We are using the we are using the lens in the specs. What is the use of the specs? For seeing the object clearly. For seeing the object clearly. Okay, already we know that in the eye there is one lens that only converge the rays from the object and that form the image on the retina. Then only we can infer the object. Yes, this is the work for the work is the eye. Yeah, this is the work for the eye. So when the eye is damaged, we wear the specs. Understand? So the lens also doing in the specs, the lens is present. The lens also doing that converging and diverging the rays. Then only we can see the object through the eye. So what is the image formation is formed by the concave and convex lenses. Understand? How the image formed? Image formed due to the refraction. Due to the refraction through a convex or concave lens. Okay, how the image is formed? We can see that. Now, when an object is placed in front of a lens, the light rays from the object falls on the lens. Falls on the lens instead of the eye lens. Instead of the eye lens, the light rays fall on the lens, on the specs. Specs lens. The position, size, and nature of the image formed can understand. Okay, so then only we can see the object. Okay, they are having certain rules. The specs, the other convex and concave lens having certain basic rules for the image formation. Okay, now we will see that. Yes. First rule. What is the first rule? When a ray of light, first upon you see the picture. First upon you see the picture. The first in the picture, in the first picture, what is the lens? Convex lens. Next lens is concave lens. Okay, the first lens is convex lens. Second lens is concave lens. In the first lens, the center point is O, optic center. Okay, optical center. Optic center or optical center, both are same only. Okay, so optical center. Next, here F1, this side F1, because two surfaces, two spherical surfaces are in the convex lens. Okay, here also two spherical, two inverse surfaces, refracting surfaces is present. Okay, here two refracting surfaces. So F1 and F2 is the focus, principal focus. Principal focus. This convex lens, so the focus point, that is F1 and F2. F1 and F2. Okay, yes. Now, when a ray, this is a parallel ray. Okay, next. So, first, the a ray passes through the optic center. When a ray passes through the optical center, it continues to follow its path without any deviation. Without any deviation. Okay, it continues to follow its path. The ray will go through that side only, through that path only. Okay, when a ray of light strikes a convex or concave lens at its optical center, okay, go through that continues to flow its path without any deviation. Without any deviation. Okay, without any deviation. Next upon, there is no image formation. There is no image formation. Suppose a ray pass through the optical center. This is the first rule. Next is second rule. When rays pass through the parallel to the principal axis. What is the principal axis? This is the principal axis. This is the principal axis. Yes, isn't it? So when a ray when the line is drawn through a line is drawn through the optical center is called the principal axis. Principal axis. When a ray pass through the convex lens at the parallel to the principal axis. Parallel means what? The principal axis to the parallel to the principal axis. That ray emerge out, refracted out through the focus, principal focus. Through the principal focus. Okay, through the principal. This is the principal focus. Understand? Yes. Next upon here onwards. This is the concave lens. Here also, the ray pass through the parallel to the principal axis. Parallel to the principal axis that refract to the principal focus. Refracted to the principal focus. Here convergent. Here convergent. First is the converging. Here diverging. So that only that will return back to the principal focus. Okay, this is the converging lens. This is the diverging lens. Yes. Next, rule 3. When a ray passing through the principal focus, directed towards the principal focus. This is the principal focus. F1 is the principal focus. The ray refracted will be parallel to the principal axis. Principal axis. Now, the ray, this is the incident ray. This is the, see the arrow mark. This is the incident ray. This ray passed through the principal focus, that is refracted in the lens, and then refracted ray will be parallel to the principal axis. Will be parallel to the principal axis. It is in the diverging lens, diverging concave lens also, the ray passing through the focus, principal focus, and then that will refracted ray will be parallel to the principal axis. Parallel to the principal axis. This is the rule 3. Okay, so these 3 rules will be followed in the image formation. These 3 rules will be followed in the image formation. What is the first rule? Suppose an incident ray pass through the optical center, no deviation, so that go in a straight line. Okay, and then the rule second. What is the rule second? When a ray pass through the parallel axis, parallel to the principal axis, parallel to the principal axis, that will emerge refracted, emerge out to the principal focus. Okay, and then third rule, what is the third rule? When the ray pass through the principal focus, refracted ray will be parallel to the principal axis. Will be parallel to the principal axis. These 3 are the rules. And then refraction through a convex lens. Now we'll go to the formation of images. Okay, first upon the object at infinity. You see in this picture. First upon you see in this picture, the infinity means far away from the lens. Far away from the lens. Okay, here one lens is present means here one lens is present in. This is the object will be the tree or a building. Tree or a building. So far away from the lens. Far away from the lens. So here what is this? Infinity. The real image formed the principle. The incident rays falls on the lens. Incident rays falls on the lens. Here also optics center. The O is the optics center. First upon you notice this. First upon O is the optical center. F1 is the principal focus and 2F1. Okay, the F1 and the 2F1 is the same distance only. That is called the C point, C1 and C2. C1, center of the curvature. That is called the center of the curvature. Okay, so that is indicated by the letter C1. This side, this left side, and then right side also F2, 2F2, C2. Okay, so we draw one straight line through the optical center is called the principal axis. Okay, va? Now we go the rays from the tree falls on the convex lens. Okay, va? And then they converge at one point. Which point? Principal focus. Converge at one point. Converge at one point is called the principal focus. Okay, ma? The image also formed at the principal focus. Okay, ma? That is a point size image will be get. Okay, ma? The object is very big, but the image is very, very small. Okay, so when an object is placed at infinity, a real image is formed. Infinity means what? Far away from that. We don't know the distance between the lens and the object. Okay, wow, that is called the infinity. Okay, wow, infinity, a real image is formed at the principal focus. The size of the image is much smaller than of the object. Okay, wow. So that I said very, very small image we will get. Okay, well, this is the first image formation when the object is at infinity. Okay, well, next when an object is placed. Now, first upon you see the diagram, convex lens. So this is the optical center already as it is. Okay, well, next principal axis. The principal axis F1 to F1. Here C1. Not represented. Don't bother about that. This is C1. Next upon here F2 to F2 C2. Understand? Yes. Now the object is beyond the 2F1, beyond the C, beyond the C. So 2F1 is also called the beyond C. Okay, beyond C, the image only you take two rays. Okay, two rays that falls on the of one ray is passed through the optical center, another one ray is falls on the converge lens, that is convex lens, and then the two rays join. Okay, formed at the formed image at the center of the is formed between the center of the curvature and the principal focus. Okay, the two rays join and form there. Yeah, when the two rays converge at that place, the image will be formed. Understand? Image will be formed. What is the place? What is the place, ma'am? Sir, in between the C and the F. C and F. Okay, ma'am. So when an object, you see that when an object is placed behind the center of curvature, a real and inverted image is formed between the center of the curvature and the principal focus. Okay, size of the image is the same as that of the object. Understand? Same. The object. Yes, sister.
10 minutes remaining, sister.
That is the same size. That is the same size. Okay, object and image are same size. Okay, next the object placed at the C. Object placed at the C. So now we keep the object at C. Okay, the two rays passed through the convex lens and then they converge at one point. Where? C. Center of curvature. When the object is placed at the center of curvature, at the left side, the real and inverted image is formed. At the other center of the curvature, other side of the center of curvature. Understand? The size of the image is the same as that of the object. Same as that of the object. Do you see that? 2F1, C, and then place it. We keep the object in the at C. First one is beyond C, this at C. That is two rays converge at the opposite side of the center of the curvature. Understand? So size of the image also same. Next, object between F and C. Object between F and C. Object. F. Now first of all, beyond C we keep them, and then at C. Now third one is in between the principal focus and the C1. Okay, wow. When an object is placed here, the two rays go through the optical center and the lens that will be focused beyond the C. Beyond C, the opposite side. Understood? You see the diagram first. Beyond C, the object, the image will be, size of the image will be very big. The image will be very big, bigger than the object, bigger than the object, understand? So, beyond C, bigger than the object. Okay, so when an object is placed in between the center of the curvature and the principal focus, a real and inverted image is formed behind the center of the curvature. Okay, the size of the image bigger than that. This is small, but the image is bigger than the object. Yes. Next, object is placed at the principal focus. Principal focus. Okay, now the object is keep at focus. Okay, focus, principal focus. What will happen? The two rays passed through this. All the rays, we take only two rays. All the rays will be in all sides. The rays will be passed through the optical center and the near point. Near point. Near point means near the optical center. That will be below or up. Okay, so that will go and to the F2. F2 means what? Focus. One ray is passed through the focus. Another one ray is passed through the optical center. But they are parallel. Parallel means what? Already told. Parallel means inaya. That will not coincide. That will not intersect. That will not intersect. So the image formation we can't see that. Image formation we can't see. Okay, so when an object is placed at the focus, the real image is formed at infinity. Infinity means no. That is far away from us. We can't see. Okay, so infinity. The size of the image is much larger than that of the object. Much larger than, very big than that of the object. Understand? Yes. Now, next, object placed principal focus, and then in between the principal focus and the optical center. Principal focus and the optical center. What will happen? The image will fall. A virtual image is formed. The size of the image is larger than that of the object, but that will be at the left side only. That will be at the left side only. Understand? Now, you see this. You see in this picture, the red part is the object. The red part, red arrow mark is the object. The two rays pass through the convex lens. Two rays pass through the convex lens. The one ray is passed through the optical center, and then another one ray is passed through the focus. Focus lens. This is the center of curvature, F2. F1 is the principal focus. This is F2. So C, center of curvature. And then that image, the rays will make an image, virtual image, not the real image. That is a virtual image. So the two rays will converge at the left side only and make a large, very big, very large image in between the F1 and F2. F1 and F2. A to A dash means what? Where that is bigger than, larger than that of the object. Understand? So, object placed between the principal focus F and the optical center O. Principal focus, a virtual image is formed, not the real image. The size of the image is larger than that of the object. Larger than that of the object. Okay, this is the image formation. Okay, yes. Today, you draw the pictures only for the image formation. Okay, I send the question through the WhatsApp. Only the image formation. Diagram only you draw today. Okay, understand? You try to understand and draw that. After that, we learn the answers. Next, applications of convex lenses. What are the applications? Applications means what? Uses. Okay, so convex lenses are used as camera lenses. Convex lenses only used in the camera. They are used as magnifying lenses. Magnifying lenses. Okay, next, they are used in making microscope, telescope, and slide projectors. And slide projectors. Okay, they are used in making microscope, telescope, and slide projectors. And then they are used to correct the defects of vision called the hypermetropia. Okay, yes, they understand this now. Next is refraction through a concave lens. Refraction through a concave lens. The formation of images by a concave lens when the object is placed at two possible positions. Only, this is only two or three only image formation. Here, object at infinity. Object at infinity. A virtual image is formed at the focus. Where here also in the concave lens also, when the object is at infinity, the image is formed at the focus, but at the same side. But at the same side, not in the opposite side, in the same side only. At the infinity, virtual image is formed because the refracting surface is inverse. Inwards. Okay, understand the size of the image is much smaller than that of the object at infinity. Okay, here two rays, here also two rays, one is that is one, another one is this, that is that refracted by the refracting surface and then converge that point F1. This is principal focus. Okay, next object principal axis. When the object is in the principal axis, where is the object? Here, that is the object. Okay, so before, if at the end, the virtual image is formed optical center in between the optical center and the principal focus. Okay, this is the A and B is the object. Two rays refracted by the concave lens and then form the virtual image at focus